So in this video, I wanted to show you guys how to solve system of linear equations using the addition method, also known as the elimination method. The addition method is ideal when both equations are in standard form. So notice that these two equations are in standard form. What that means is that the x and y term are on one side of the equation and the constant term is on the other side. So we call this the addition method because we're going to add the two equations. Notice that the x term has opposite coefficients. So we have 3x and negative 3x. If we add these two equations, what happens is the x's are going to be eliminated. So hence, that's why we also call it the elimination method. So let's add these two equations. So 3x plus negative 3x is 0, right? It cancels out. 5y minus 2y gives me 3y is equal to 11 minus 8 gives me positive 3. So from here I can divide by 3, right? So 3 over 3, that's just 1. Y is equal to 1. 3 over 3, again, that's equal to 1. All right, so we know that a solution to a system is an ordered pair. And what we just found there was the y coordinate. So the y coordinate is positive 1. How do we find the x coordinate? We can then just go into either one of these equations. So I can use the first equation or the second equation, it doesn't matter. I'm going to use the first equation because that's the first one I see to solve for x. So we're going to solve for x, and I'm just going to recopy the first equation. Oops, I messed up there. We're solving for x. We don't know what x is, so that's 3x plus 5y. We do know what y is. Y is equal to 1, is equal to 11. So substitute in 1. We get the following. We get 3x plus 5 times 1 is 5 is equal to 11. And we're going to subtract 5 from both sides. It zeroes out. I get 3x is equal to 6. And then divided by 3. 3 over 3 is 1. 1 times, 1 times x is equal to 6 divided by 3 is 2. So my x coordinate is positive 2. All right, so this is my solution to this system here, and that's using the addition method. So let's go through another one just to get a little bit more practice. So for example, in this problem, we want to solve using the addition method, and we notice here immediately that the y term has opposite coefficients. So I'm going to add the two equations, and what happens is the following. Let's see, 2x plus 3x is 5x. And then 9y minus 9y, that cancels out. They're eliminated, right? On the other side, I get 1 minus 21. That gives me negative 20. And we can then solve for x by dividing by 5. So let's see, 5 over 5 is 1. 1 times x is x. And negative 20 over 5, negative 20 divided by 5 is negative 4. Again, we're not done yet. What we just found is the x coordinate. X coordinate is negative 4. We then need to find the y coordinate. So to solve for y, I can use any equations. For this one, I'm going to use the second equation. All right, so we have 3. We know what x is, so we're going to substitute negative 4 for x. 3x minus 9y equals negative 21. And x is equal to negative 4. So let's work this out. 3 times negative 4 is negative 12 minus 9y equals negative 21. And just solve for y. So we're going to add 12 because we want to get y by itself. This zeroes out. 0 minus 9y is negative 9y is equal to negative 21 plus 12. That gives me negative 9. And then divided by negative 9. The negative 9s, they cancel out. So I get y is equal to negative 9 over negative 9 is positive 1. So there it is. Here's my solution to the system of linear equation. Let's go through one more problem. So let's look at, actually this is a good one to look at. This one's a bit tricky. I'm going to delete these because I'm going to need this space right here. Again, it's always good to start with knowing that a solution to a system is an ordered pair that contains an x and a y coordinate. So in this case, you might look at this and you notice that these are opposites, but they're not the same coefficients. I only chose y because I can definitely choose x, but I chose y because that seems like the easier one to solve, to eliminate. So what do? How do I eliminate this equation if they're not the same or they're not opposite coefficients, right? So up here, if you guys remember, we had opposite coefficients. Here we do not have opposite coefficients. Here's what you do. What you want to do is you want to multiply one of the equation by a number so that they would, so you would get opposite coefficients. For example, if I were to multiply the top equation by 3, again, you got to multiply both sides by 3, right? When I distribute, notice how I'm going to get 3 times minus 2 is going to give me a minus 6, which then gives me opposite coefficients. All right, so let's see what that looks like. So 3 times 3x is 9x. 3 times minus 2y is minus 6y. And on the right side, 7 times 3 is 21. So let me recopy the second equation here. I'm just going to recopy it down here. 7x plus 6y equals 27. And now I have opposite coefficients, which would allow me, if I add the two equations, to get rid of the y's. So I'm just going to do just that. So I'm going to add the two equations. 9x plus 7x is 16x. This zeroes out, is equal to 21 plus 27 is 49. I'm sorry, 48. And then divided by 16. 16s, they cancel out, right? 16 over 16 is 1. So you get x is equal to positive 3. So what I just found there is the x coordinate of the solution. I then now have to solve for the y coordinate. And again, I can choose either equation. I'm going to choose the first one. So that is 3x. I know what x is. I know I'm going to substitute 3 for x. Minus 2y equals 7. And substitute in 3 there. So I get the following. I get 3 times 3 is 9. Minus 2y equals 7. And I'm going to subtract 9 from both sides. This cancels out. I get minus 2y equals, sorry, so this was a problem I worked out already earlier, but I'm going to delete that. 7 minus 9 is negative 2. So divide by negative 2. The negative 2 cancels out. Y is equal to positive 1. Negative 2 over negative 2 is positive 1. So this is my solution to the original system there. All right, so hopefully that was helpful. If you have any questions regarding anything, shoot me an email. Sometimes you may have to multiply both the equations by a number, meaning you might have to multiply the first equation by a number and then the second equation by another number to get opposite coefficients so that you can eliminate one of the variables. And again, sometimes you just have to eyeball which one is easiest to get rid of. I can definitely get rid of the x's, but that's going to take a little bit more work. Here, I recognize that if I just multiply this equation by 3, I can get opposite coefficients, and that's why I went with the y's. All right? All right, so hopefully that was helpful.